Hey again, it's Mr. Lum, and we're going to be talking about trial KEQ. So a trial KEQ is a number that you compare to the real KEQ to see which way the reaction is going to go. I usually call it trial KEQ. I think the textbook sometimes calls it Q, but I'll explain what it means in a second. So here's an equation right here. It says A plus B turns into or forms an equilibrium with C, and the KEQ is 3.5. So in the reaction, we have placed in the reaction vessel is 1.5A, 1.25B, and 4.1C. And it's and that's supposed to be molarity, 4.1C, molarity C. And we don't know if it's going to be causing, if it's at equilibrium right now, or if it needs to shift left or shift right. So what we're going to do is we're going to do a trial KEQ. So we're going to take the concentration, just like real KEQ, it's the concentration of products divided by the concentration of reactants. I plug in my values. So trial KEQ. Trial just means like a test on KEQ. So it's going to be 4.1 molarity divided by 1.5 and 1.25 right here. So trial KEQ equals, and I take my calculator and type in 4.1 divided by 1.5, and then 25, I get 2.18 or 2.19 if I round it, 2.19, and there's no units for trial KEQ. So now I'm going to be comparing my trial KEQ, and I'm going to compare it to my real KEQ. Now my trial KEQ is too small. It needs to become bigger. So in order for trial KEQ to become to turn into 3.5, like currently it's at 2.19, it needs to increase in size. So what that means is that the products need to get bigger, the reactants need to get smaller. For 2.19 to be 3.5, the products need to be bigger. Or in other words, it needs to shift to the right. So we'll say that this reaction, if you put this much A, B, and C in there, this will be shift right. Because the trial KEQ is currently too small. It needs to increase in size. So the only way it can increase in size is that the products need to be greater in value. And so how do we get more products? Well, we're shifting to the right. And that brings us to this, like, if the trial KEQ is larger than the KEQ, that means the trial KEQ is too big and it needs to shift to the left. If the trial KEQ, like in that previous question, is too small, so the trial KEQ is less than the KEQ, it needs to shift to the right. And if trial KEQ is equal to KEQ, then that means it's already at equilibrium. There's no shift. So let's take a look at this next question right here. So we have A, B, and turns into 2C right here. So we're going to do a trial KEQ. And we know what real KEQ is, and we want to see, is this thing at equilibrium or is it going to be shifting? So we're going to go, C is 3.25 squared, because of that, divided by our reactants, 1.5 and 1.5. And so I take my trial KEQ, and I go 3.25, square it, divided by 1.5, and again, I get 4.69. So my trial KEQ is a tiny bit too big. And that means since my trial KEQ is a little bit big, okay, it's going to be shifting to the left. Okay, so it's going to shift towards the reactants. So shifts left. Or in other words, if you want to just like think about it conceptually, is that this number right here is too big compared to this. So how can we make this number smaller right here? Well, we can make this number smaller by decreasing the products. So the products would have to go down. Or in other words, we can increase the number of reactants, and that would also make it smaller. Or in other words, we would just say simply it needs to shift left. Okay, let's take a look at this reaction right here. It says that we have a KEQ that's equal to 10. It also says that we start with 10 moles of NH3 in a 5-liter container. So 10 moles of NH3 is the equivalent of 2 molarity. N2, a 5-liter container, is 3 molarity. And 10 moles of H2 is in a 5-liter container is 2 molarity as well. Okay, so 10 moles of NH3, 15 moles of N2, and 10 moles of H2 are all put into a 10-liter container. It is left to react. We don't know which way it's going to shift since we started with reactants and products in there. But we do know what the KEQ is, so we can calculate which way this reaction is going to shift. So we're going to go trial KEQ is going to be our products. And I had to make sure I cubed the right ones and squared the right ones. So trial KEQ is going to be 3 molar times H2, which is 2 molar, cubed, over NH3, which is 2 molar, squared. Trial KEQ, 2 cubed is 2 times 2 is 4, times 2 again is 8. 8 times 3 is 24. 2 times 2 is 4, or trial KEQ equals 6. Now, the real KEQ is 10. The real KEQ is 10. So that means the trial KEQ, it's too small. It needs to get bigger. So that means it's going to be more products. These products need to get bigger. So that means it needs to shift to the right. So which way is this going to be shifting? Shifting right. Okay. Let's take a look at this reaction right here, and then let's figure out how much A, B, and C do we get at the end of this thing, okay? So let's take a look at this reaction and do it in its entirety. So we have A plus B turns into 2C. I'm going to write an ice table, right like that. We start with 1 molar of everything. Okay, Now, trial KQ, it's nice and easy, is going to be the products, which is 1.0 squared, over the reactants, 1.0 times 1.0. And trial KEQ simply equals 1. Now, trial KEQ is too small compared to real KEQ. So that means it must shift to the right. We need more products. We need the KEQ to be bigger, so we need the products to be bigger. So that means this is going to be increasing by a factor of 2x, the 2 because the coefficient of 2 right there. And that means this is going to be decreasing by a factor of x and decreasing by a factor of x right there. 1 plus 2x is 1 plus 2x. 1 minus x is 1 minus x. 1 minus x is 1 minus x. Okay. Now I want to figure out how much A, B, and C I have after this thing clearly shifts to the right, because we just said that, hey, this thing is shifting to the right. So I want to figure out how much A, B, and C I have left after this thing comes to equilibrium. So I'm then going to put in my KEQ expression, which is going to be C squared over AB, or in other words, it's going to be 3.5 equals 1 plus 2x, and please remember that that is squared, over 1 minus x, and please remember, since we have 2 of them, we can simply say that it's squared. Take the square root of both sides, and the square root of 3.5 is 1.87, and that equals now 1 plus 2x over 1 minus x. Time both sides by 1 minus x, so I'm going to get 1.87 minus 1.87x equals, let's try that again, equals 1 plus 2x. I am then going to add 1.87x to both sides, and that's going to be 1.87 equals 1 plus, and then 2 plus 1.87 is 3.87. I'm going to subtract 1 from both sides to get rid of this 1 right here. So minus 1, minus 1. So I get 0.87 equals 3.87x. And then finally, I'm going to solve for x and go 0.87, typing in my calculator, 0.87 divided by 3.87 equals, and I get 0.2248 or 0.225, and that's x. That isn't my concentrations of A or B. In order to find the concentration of A now, I need to plug x. I need to plug x into this. So I need to go 1 minus 0.225, and that's my new concentration of A is going to be 0.775. Write it a little bit nicer. 775 molarity. And B is going to be the same, of course, 0.775 molarity. And then C, the concentration of this is going to be 0.225 times 2, and then 1 is going to be added to it. Or in other words, you're going to be taking this 0.225 and plugging it into that 1 plus 2x equation right there. So 0.225 times 2 equals 0.45 plus 1 equals 1.45. Okay? And that's our answers right there. Let's get a little practice on some trial KEQ stuff. Page 71, questions 54 and 55. I think that'll help you out. And yeah, and then continue working on that KEQ worksheet.